All right, everyone. So, as of right now, which is Monday, September 23rd at 7:22 p.m., I should have everybody's grades up to date in Skyward. Please check that and email me if you think that you have sent me something and I have not put it in the grade book. I am human. I may have looked over it, and I just want to make sure everybody's grades get in. The end of this quarter is this Friday, so if you have zeros, you need to get those things in and email me once you have submitted them into Seesaw. I will be checking Mathia on Thursday and probably Friday as well, seeing if anybody's got any more complete. If you are missing a test grade, like have a complete zero in the grade book, you need to contact me about taking that test. The links that are in Kidem are not going to work. The test expired. You were supposed to take it on the day it was assigned. You didn't take it. So you need to contact me about taking that test. I have not put in test corrections yet. I will do that by Friday, and it will be on this quarter. All right. But today we are going to be solving quadratics by the square root method. So your warm-up is to simplify the following square roots. These are perfect square roots. You should know them by now. If not, you should probably try to learn the perfect square roots, especially if the number's up to like 15. So you're going to go ahead and answer these questions, and then when you come back, I'll give you the answer. So the square root of 16 is 4. If you are confused about how to do square roots, you are simplifying 16 into primes, which this really isn't primes, but you're simplifying it into two things that you can pull out from the square root. So you're looking at like 4 times 4, because you can pull out both of those 4s and it'd be equal to 4. 49 is 7 times 7. 121 is 11 times 11. And 81 is 9 times 9. So our learning goals for today are I can identify the zeros of a quadratic function, the roots of a quadratic, and the x-intercepts of a parabola using the equation of a quadratic function. Hopefully that you remember that zeros, roots, and x-intercepts are all the same thing. I can also solve quadratic functions using square roots, which is a lot of what we're doing today. So now I'm going to kind of go over with you how to simplify. I don't know how to make that go away. How to simplify non-perfect square roots. I'm going to show you two methods, and you can kind of choose which one you like more. And I have my favorite, and it's probably what I'm going to do, and it's going to be the second one I show you. But if you are comfortable with the first one, you're more than welcome to use it. So the first one would be to simplify this into a perfect square root that you can simplify out and the square root of a prime number. So, for example, to get 20, you could do 4 times 5. So you're doing the square root of 4 times the square root of 5, which equals the square root of 20. We can simplify the square root of 4 to 2, but we still have that square root of 5 because it does not simplify out. And you can even put that in a calculator and see that. So the other way that I like to do it is I like to kind of make a factor tree. So 20 divided by 2 is going to give me 2 and 10. And 10 divided by 2 is going to give me 5. And there's several ways you can do it at this point. You can circle the things that you can pull out, because remember, you have to have a pair to pull out. So you could just straight know that it's 2 square root of 5, or I like to rewrite it as 2 times 5, or that's a 2, sorry, times 5. And then I see that I can pull out those two 2's and get 2 square root of 5. So you can do whatever you would like, but pretty much you're just going to simplify the square roots either till you can simplify it because it is a perfect square root, or make a little factor tree and go from there. So we're going to do some together, and then there's some, I guess we're just doing some together. I thought there were some that you did yourselves, but we're just going to do some together, I guess. So if we're looking at 120, if I were to make a little factor tree of 120, I would do 2 divided by 2 just because that's easy. Actually, let's do divided by 10 so this doesn't get too crazy. So we'll do divided by 10. So we'll be looking at 12 and 10. So it'll be 2 and 5, 2 and 6 can go into 2 and 3 because we're getting it into complete prime numbers. So here's where you got to go and find where you ended. So this can get a little messy sometimes. So we're looking at 2 times 2 times 2 times 3 times 5. So and then you notice that we can only pull out one set of 2's. So this is equal to 2 square root of 2 times 3 times 5, which would give us 30. And this right here would be your final answer. Which I'm going to erase that. I'll leave it there for now. All right, so then if we were to come over to number 2 and make a factor tree, I would divide by 5 and 7, which if you were to then do 5 times 7, there's nothing that we can pull out. So our final answer here is still just going to be the square root of 35. That is in its simplest form. If we were looking at 98, I would divide by 2. You get 49, which I recognize as 7 times 7, and hopefully you do as well. So you have 2 times 7 times 7. You can pull out the 7's. So it'll end up being 7 square root of 2. All right, so number 4, there's something very different here, and that would be that negative that is under that square root. So the answer here is going to be no real number. And the reason for that is because there is no real number that is going to give you a negative underneath your square root. So no real number squared is going to be a negative number. All right, so let's go down here to number 5. And we're looking at 24. So I would divide by probably 2 again. I like doing 2's because whenever you do 2's, there's not really a good example, but you can kind of go down the side with it to find all of your numbers. So this will be 2 times 12, 2 times 6, and 2 times 3. So we're looking at 2 times 2 times 2 times 3. So we can pull out one set of 2's, and this will be 2 times square root of 6. So then over here, we'll make a factor tree of 128. So it'll be 2. I do 2 again. I like 2. So 64. And hopefully at this point you recognize that 64 is 8 times 8. If you don't, your factor tree is going to get a lot longer. So at this point, you could go ahead and jump to the square root of 2 times 8 times 8. And know that you're going to have 8 square root of 2 as your final answer. You could keep going into 2's, but you're just going to have a lot more factors. That's why it's so important to know these square roots that just are perfect. So I'm actually going to erase this and move this down so that we can work on that 99. So we're looking at 8 square root of 2 down here. So 99, I would do 9 and 11, and I know that 9 is 3 times 3. So we're looking at 3 times 3 times 11. So we're looking at 3 square root of 11. And then finally, 550, which looks like a very, very big number, but the first thing I would divide it by is 5, because then we're down to 110 already. I would divide that by 5 again, and we're at 22. So 2 and 11. So this is 5 times 5 times 2 times 11. We can pull out those 5's. So we're looking at 5 square root of 22 because we have to multiply that 2 times that 11, and that's our final answer there. Hopefully you feel comfortable with these. If not, I believe that there's some more practice in your homework. Pretty much it's just making factor trees and simplifying what you can. And you can only pull out something if you have 2 of it because we're talking about square roots here. All right, so go ahead and flip your packet over. I probably forgot to tell y'all, but this packet is linked in Kidem on the plan book on today's date if you need it. Or if you just want to take notes straight, you can, whichever you prefer. Okay, so now we're going to keep going. So now that we know how to simplify square roots, let's solve quadratics by taking the square root. So solving quadratic equations by rearranging and taking square roots. So when should I solve using this method? You should use this method when we are in vertex form, which hopefully you remember from the last test. If not, I will write it up here so you can remember. So it's when f of x equals ax minus h squared plus k. Or when the equation is written in standard form with no bx term. So again, standard form, hopefully you remember, but here it is. Ooh, we haven't even equals ax squared plus bx plus c. So this would be when we are missing that bx term. So it would just be ax squared plus c. So how do we use this method? So we're going to isolate the squared term. We're going to square both sides. And remember that we're going to have a plus and a minus sign. And then we're going to solve for x. So let's try a couple of these together. I'm going to leave the step-by-steps up there. So isolate the square term. So for number one, our square term is already isolated. So then we're going to take the square root of both sides. And x will equal plus or minus 5, because the square root of 25 is 5. That's a perfect square, one of which you should know. And that's your final answer. So then we'll go to number 2. And so we have to isolate our x squared. So we're going to have to divide by 2 because we're just solving to get x squared alone. So we're going to divide by 2 on both sides. So we're looking at x squared equals 49. And then we are going to take the square of both sides. So we'll take the square root of both sides. And so we will be looking at x equals plus or minus 7, because the square root of 49 is 7. It's, again, a perfect square, something that we need to know. Let's come down here to number 3. And again, we're going to have to isolate that x squared. So we're going to add 16 to both sides because we have to get that alone. So we're looking at 9x squared equals 16. We're going to divide by 9 on both sides. So we'll have x squared equals, and 16 divided by 9 is not perfect. So that'll be 16 divided by 9, and we're going to take the square root of both sides. So we will be looking at x equals, which at this point you can take the square root of 16 divided by the square root of 9, which, actually, let's keep working down. So then you will know that the square root of 16 is plus or minus 4, and the square root of 9 is plus or minus 3. So it'll be plus or minus 4/3. All right, so let's go up and look at number 4. So here is when we are in that vertex form. So because our square is isolated, so we can go ahead and take the square root. So we're going to take the square root of x minus 2 squared and the square root of 25. So this will give us x minus 2 equals plus or minus 25. So then to get x alone, what we're going to have to do is going to have to add 2, but we're going to have to add 2 to both of these numbers. So if you want to, you can write x equals 25 and x equals negative 25. So, but we're going to have plus 2 and plus 2. So x equals 27 and x equals 23, or not 23. So we're looking at negative 25 plus 2 is negative 23. Sorry, I forgot the negative in that. All right, so now we're looking at number 5. And so we're in vertex form again, but we have this plus 9 that we're going to have to get rid of to isolate our squared term. So we're going to subtract 9 from both sides, and we will then have x minus 2 squared equals 25 minus 9, which will give us 16. So then you'll have the square root of both of those. So you'll have, we'll have x minus 2 equals the square root of 16, which is plus or minus 4. So then you can come up here and write, which will write x minus 2 equals 4 and x minus 2 equals negative 4. So plus 2 plus 2 plus 2 plus 2, x equals 6, and x equals negative 2. And then we will come down here to number 6. And so we have a lot more this time with that x squared term. So this time we're going to subtract 9 again. And that'll be 4x minus 2 squared equals, and again, we have 25 minus 9 again, so that'll give us 16. But then we have to divide by 4. And 16 divided by 4 is 4. So we're looking at x minus 2 squared equals 4. And we're going to take the square root of both sides. So we're going to have x minus 2 equals, and we'll go ahead and do the plus and minus. So square root of 4 is 2 and negative 2. So then we'll add 2 to both sides. And our final answer is x equals 4 and x equals 0. All right. So now you're going to try some of these on your own. I will help you get started on a few of them, but not all of them. this number 7, you know how to do it. So go ahead and get started, input your answer, and then when you come back, I will go over the answer. All right, so the first thing that we're going to do is divide by 8, which hopefully you did. And hopefully that you got that was 25 equals x squared. Take the square root of both sides. You got x equals plus or minus 5 is your final answer. And in plan book, you'll just put x equals 5 and x equals minus 5 would probably be the best way to go about it. For number 8, again, you can do this one on your own. You shouldn't need my help. So go ahead and do it, and then when you come back, I'll go over the answer. So we're going to subtract 84 from both sides. And you're going to get negative 4x squared equals negative 80. You're going to divide by negative 4. And negative 80 divided by negative 4 is going to give you 20. So take the square root of x squared and 20. And square root of 20 is not a perfect square, so you will get x equals the square root of 20. So it's going to do a factor tree. So 2, 10, 2, 5. So it'll be 2 times 5. So x equals plus or minus 2 square root of 5 will be your final answer here. All right. Actually, I'm probably not going to have y'all input this one now that you're thinking, what? She didn't make me input it. It's because of that square root. And if I ever do make y'all input anything that has a square root, just type SQRT and then in parentheses, you would put a 5. If you ever needed to input that into PlayPosit. All right, so number 9, you'll be able to enter this answer, so go ahead and do it. Hopefully you added 9 to both sides, so you would have x minus 1 squared equals 9. With the square root of both sides, you would have x minus 1 equals plus or minus 3. And your final answer would have been x equals 4 and x equals negative 2, because you would have had to add 1 to both of those. All right, I actually think y'all can do number 10 completely fine as well on your own. I think it's some problems later that I'm going to have to help you out a little bit with. So you're going to subtract 4. You're going to have negative 3x plus 5 squared equals negative 27 divided by negative 3 divided by negative 3. X plus 5 squared equals 9. Square root, x plus 5 equals plus or minus 3. And then your final answer here, you're going to have to subtract that 5 from both sides, should have been x equals negative 2 and x equals negative 8. Yes. Okay. All right, and if you have any questions about this, please message me, okay, on Remind or on an email. Because now we're going to move on to the zero product property. So the zero product property states that if the product of 2 or more factors is equal to 0, then at least one factor must be equal to 0. So here's a worked example right here. You can use the zero product property to identify zeros of a function when the function is written in factored form. And remember, zeros are x-intercepts and solutions and roots, a little bit of everything. So you'll have to have it equal to 0, which I think down there at the bottom when there's some problems where you try it. Just kidding, they're already equal to 0. I was lying. So it'll be 0 equals x squared minus 16, which none of these down here have it. These are already in factored form for you. So you're going to rewrite the quadratics as linear factors. That's already done for you on these. And then you're going to apply the zero product property. So you're going to write each factor equal to 0, and then you're going to solve for x. So we're going to do a couple together, and then it's these try that I have to help you out a little bit to get there. But so we're going to write each factor equal to 0, because these are factors. So we'll have x plus 2 equals 0 and x minus 2 equals 0. So then you just solve for 0. So minus 2, x equals negative 2, not 3. Plus 2, and x equals positive 2. And these are your solutions. So if we go down and look at number 2, we're going to have 2x minus 3 equals 0. 2x plus 3 equals 0. And then you're going to solve for x. So we'll add 3, 2x equals 3, divided by 2, divided by 2. So x equals, that's actually not right there, because we're going to be right there in a minute. So x equals 3 halves, minus 3, minus 3, x equals negative 3, and I wrote a 2, divided by 2, divided by 2. So x equals negative 3 halves. So these are your answers there. Up here, we're going to have x plus 5 equals 0 and x plus 5 equals 0. Minus 5, x equals negative 5. And as you see when you get over here, x still equals negative 5. So this is an example of when the quadratic hits at one point on that x-axis. Hits at that point and bounces right back up. All right, so then we're going to come down here. We're looking at 3x minus 7 equals 0 and x plus 2 equals 0. Plus 7 on both sides. 3x equals 7 divided by 3 divided by 3. X equals 7/3. And x equals negative 2 over here. And those are your solutions there. So it's down here with these try your owns that I was going to help you out a little bit. So for these factors, even 3 is considered a factor here. So it's actually 3 equals 0, x minus 4 equals 0, and then 2x plus 7 equals 0, which in 3 equals 0 is not true, so we're not going to do anything there. We're kind of just going to ignore that factor that's there. So just solve the other ones for x. So go ahead and do that, and then come back and check your answer. All right, so this will be x equals 4, because you'll add the 4 to both sides, and this will x equals negative 7 divided by 2, because you're going to subtract that 7 and then divide by 2. And then the same thing over here, you're going to have that negative 1 equals 0, which isn't true, so we're just going to ignore it. So x plus 10 equals 0, 3x plus 4 equals 0. You'll get x equals negative 10, and x equals negative 4/3. All right, so your homework is also going to be linked on Planbook. It's going to be the other PDF at the top. Go ahead and get that done and submit it into Planbook for me. None of this material that we've covered since our last test is going to be on these quarter grades. So still get those submitted, but do not be looking for them in the grade book. They will not be in there for this quarter. I will see y'all again one more time before fall break. So make sure that you check my Planbook and Kid'em one more time before you go on fall break. If you have any questions, please email me. If you have a question about a missing assignment, please email me. If you got any other questions, again, email me or message me on Remind. But if not, y'all have a good rest of your day and get that homework done.